So, hello everybody. Today, this is the lecture number three in the sequence of the in the series of the fluid mechanics. Okay. So today we are going to start once again, and this is the new topic, and the topic's name is properties of the velocity field. Okay. So don't get confused. I am going to explain it. Okay. So please be with me for the whole lecture and you will get to know many things. Okay, so this one is very conceptual and very fundamental thing, so please be attentive. So now I am going to start properties of the velocity field. Okay, so for any given flow situation, so determination of anything, like we have to determine anything, right? So like property of the fluid or something like that means how will we define a fluid? Like a flow is means a fluid is in the motion, that means we can say it's flowing, right? It's a flow. So how will like if someone says describe the fluid or anything, so we have to do something, right? Otherwise we can't say like a flow. I have to define the flow, right? I will have to differentiate the flow, two different flow, two same flows. How we can say that two flows are same or two flows are different? Okay, so most of the time the properties of the fluid will be a function of position and the time. Okay, so this is not always case, like most of the cases the property of the fluid, let's say POF, okay, properties of the fluid will be a function of position and time. Okay, and after knowing this, we can say that we will find the solution of the fluid. I mean the like what's the identity of the fluid? Okay, better the lamina or turbulent, we will study this, so don't worry. But we will know the nature of the fluid, we will know the behavior of the fluid, how we can compare the two fluids to flow. Okay, so the most important thing is position and the time. Okay, so we can say that key position and time means they are overall will create a velocity field. Okay, so that's how we are going to study properties of the velocity field. Okay, so now for in case of fluid, for studying fluid we have two scenario. Okay, like if we want to study the fluid, like say study of fluid. Okay, so we can study the fluid in two ways. Okay, sorry, yeah, the first is Eulerian description. Okay, EULERIAN DESCRIPTION. Okay, so Eulerian description. The second method by which we will study is Lagrangian description. Okay, LAGRANGIAN. Okay, and description. Okay, so how both are different? Okay, so don't worry, I will explain these things with a beautiful example, so please be ready. So let's suppose one traffic is there. I don't have to draw like this. Okay, so let's suppose one traffic is there. Okay, one road is there and many of the vehicles are passing over there. Okay, vehicles are there. Okay, in the road, too many vehicles are there and passing. Okay, going here and there, anywhere. Okay, so now for this seeing the vehicle, we are having two different objective. Okay, the first one is that the objective of like if the time passes, various car will go here and there. Okay, so like the first observer is traffic engineer. Okay, so what does the traffic engineers observe? Okay, for example, like traffic engineer or any way, let's suppose what to say, the traffic light. Okay, so traffic light will take a control area. Okay, let's suppose this area. Okay, and it will keep observing like how many vehicles are passing. Okay, so let's suppose it has to be calculated average velocity. Some engineer have to find average velocity in the road. Okay, So they will not see whether this car or that car having what velocity. Okay, it will take some area and will find out average velocity. Okay, in case of that traffic light as well, they are having a system like, if 100 number of cars will pass, then the traffic light will get turned into red. Okay, otherwise it will get in yellow, yellow or green. Okay, so the objective of the traffic engineer or the traffic light would be averaging of everything. Okay, like means they have to focus over a area and number of car will get passed. Okay, so they did not worry about anything like which car is passing, what brand is there, who is driving, nothing. Okay, but for example, some car is having a tragic incident everywhere, like if anyone is drunk and driving, so they are driving it very fast from somewhere and it's uh, going or running away from the police. Okay, so the observer police is particularly focusing on this vehicle. Okay, only in this vehicle. The police is not bothered about other particles. Okay, the police is only focusing on this particular car. Okay, so so see, if the road would be like, we don't know like how much longer the road would be, how many turns are there, everything, but the police will always focus on this car. Okay, the police don't know what's the area or everything average velocity or anything. The focus of the police is only in this car. Okay, so now we have seen two reference frame. Okay, the first one is of engineer's frame, that the he want to calculate average velocity, so he have taken some area and all the cars passes away and he will take an average over all that. Okay, so it is not worrying about which particular car is there. Okay, it is worrying about he is worrying about his area, like how he defines his area and how things are very light. For example, some at 2 a.m. the average velocity is very less. At 5 p.m. the average velocity is very high. Okay, so he is taking care of on an average of every car. Okay, but the police is taking care of one particular car. Okay, and for example, if police having all the car having some drink and drive case, so police will have to focus on each and every car. Okay, so the police have to be very particular about it. Okay, so now the first case, and that means averaging velocity case. Okay, so this frame is known as Eulerian description. Okay, and this police case is known as Lagrangian description. Okay, so now how we will implement this in case of our fluid. Okay, so for example, let's say some flow is flowing here. Okay, some fluid is flowing here. Okay, and Lagrange, there is one, like say pool is there. Okay, bridge. Okay, one bridge is there, and Eulerian is standing here. Okay, he is Eulerian. Okay, and he is made a control volume in his mind. Okay, or in his paper, and he has put some put some like measurement techniques or something here. Okay, so he have taken the wire from there and he is having a computer, so he's reading everything like what is the velocity of the flow. So now what the Lagrangian say, if he want to say someone like he is measuring velocity, pressure, temperature of the fluid at a particular point like this one. Okay, so he will tell that ux by z. Okay, he will tell at a particular point and for a particular time, or having a average time over some time, and he will average all the quantity. Okay, so he have to tell that like I am focusing on that particular point and all the fluids are passing away. Okay, so he's not bothered about fluid particles. Okay, he's only bothered about the position and all the fluid is particular passing by. Okay, and for now the Lagrangian comes and he just focuses on a particular fluid particles, and he had taken his boat and following this particular fluid and just moving by this river. Okay, and he will now tell the people like I have followed this particular droplet and I am getting this. Okay, so now, and these are the two different frame of reference be used in case of fluid mechanics. Okay, so whether these two are which one is easier and which one is harder. Okay, of course Eulerian's concept is too easy, right? Like you have to just put the equipment here and you don't have to worry about each and every particles. Okay, you have to take a simple control volume and have to take averaging or some kind of steps, but you don't have to worry about each and every particles. Okay, usually they will do some aesthetically averaging. Okay, then they will get these values. Okay, and for each and every particles that's obviously difficult to do. Okay, but let's suppose how the Eulerians can be done in real world. Okay, so let's suppose we will take a part example. Okay, so let's suppose some flow is flowing here. Okay, so now what you will do, that you have to put some like anything like olive oil or kind of thing. So you will put it here. Okay, so, print your olive oil, and each droplet or each particle of the olive oil will depict the droplets of water or the particle of the water. Okay, droplets of the water or particles of the water. Okay, and you will use some laser kind of thing, and you will having a camera, and you will record each and every particle, and you will know that how that particles are varying or how the fluids are varying. Okay, so this is a kind of Lagrangian frame. Okay, and in Eulerian's flow, Eulerian description be used in our daily life, like in finding the wind velocity or anything. Okay, so we fix the equipment at any particular position and we will check. Okay, so these are the two approaches. Okay, that we used in our daily life for measuring fluid for study the fluid. Okay, so now I hope that you have getting the knowledge of this. You have getting like very clear about these two concepts, Eulerian and Lagrangian description. Okay, okay, and now two small topics are there, so I will discuss it quickly. The first one is velocity field. Okay, these are pretty simple. Okay, so I'm not have to worry about this. The main concept is above one, Lagrangian and Eulerian description. Okay, so I hope that you got it. Okay, so so for a fluid there are plenty of what to say properties. Okay, a fluid can be described by its properties, like what kind of fluid, or how it is different, how it is same. Okay, like I told you earlier, right? So properties of the fluid, the most important fluid property is velocity. Okay, most important. Okay, everything you will start from here. Okay, most important properties. Okay, so and like why velocity is most important. Okay, so let's suppose if we know the any point velocity of the particle or the fluid, like x, y, z and t. Okay, any particular point, any particular time, if we know the velocity of that fluid, we will get to know about pressure and temperature. Okay, we can find it out the pressure and temperature of the fluid as well. Okay, another question is how we will going to find this pressure and temperature. So now we will study the pressure kind of thing in chapter 2. Okay, in second chapter I will discuss this, like how from the velocity we will able to find the pressure. Okay, how the means like how velocity is devoted to the calculation of the pressure. Okay, once the velocity period is known. Okay, and many of the in heat transfer courses you will get to know that how from the velocity you will get to know about the temperature profile. Okay, so this you will study in heat transfer. So yeah, everything is related to the velocity field. Okay, so the most important property is the velocity field only. Okay, so now as you know that velocity is a vector quantity, right? So vector quantity is can be written as yeah, so velocity x, y, z and t. Okay, so in x direction we will write ui, x, y, z and t. Okay, in y direction it is written as v, u, v, x, y, z and t, plus in z direction it will be written as w, x, y, z and t. Okay, so we will represent a velocity vector each are having their own scalar values in each direction. Okay, and combining them we will say that it is a vector quantity and we will represent it as a vector. Okay. Okay, now the second point is acceleration field. Mostly we will talk acceleration field in more detail in upcoming lecture. So I'm just getting it to introduce you, so that just you have to think about it and keep in mind. Okay, whenever I discuss it over. So acceleration is defined as dv by dt. Okay, that means derivative of velocity with respect to the time. Okay, and it is only valid for Newton's law. Okay, and sorry, it is valid from Newton's law. Newton's law. Okay, we know that this formula it is valid from Newton's law. Okay, so in order to flow a fluid in Eulerian description, the acceleration field is defined as like overall dv by dt, and we know dv is equal to in the written. Okay, v, sorry, here it is, v is written here. Okay, so we can write it as dv by dt in each direction. Okay, but we have to differentiate it in x and y and z as well. So dv by dx plus v, sorry, yeah, dv by dx w dv by dz. Okay, so like these three terms, these are non-linear, right? U and another two velocity terms are multiplied by itself, so it's a non-linear term, and this is the most difficult thing. Most difficult thing to solve. Okay, that's why this NS equation, all these terms having this what to say, non-linear term, and that's why they are getting very much tedious to solve. Okay, okay, and how these things happen. So like in your mind you came up with this, like how these terms are coming, whether this is enough or not. No, this is not enough. Okay, so how we will see the dimension here. Okay, u into dv by dx. Okay, so let's suppose how this comes. Okay, so I will tell you du by dt. Okay, we will write this as this, like that. Okay, so how we can differentiate it, like du by dt into dv by dx. Okay, okay, sorry, I am really sorry. See, dv into dt divided by dx. Okay, so this will make dx. Okay, the same thing. So dv by dt get cancelled, and u into dv by dx. Okay, so the dimension remains same. That's why these terms are coming. Okay, so I hope these things are clear to you. And now I'm just getting introduced. We will discuss these things in the upcoming lectures in detail. Okay, so I'm just introducing it there by name. Okay, so now we are going to study thermodynamic properties of fluid. Okay, so let's suppose velocity is there, right? We know velocity is the one of the most important property. Okay, and it is having three base friends. Okay, the first one is pressure, temperature, and density. These are the most important and the most best friend of the velocity. Okay, so for example, these four are interdependently in case of ideal gas. Okay, so ideal gas is also a fluid. Okay, so don't think anything, keep in the mind. Okay, and the other intensive thermodynamic properties are thermodynamic properties are other three intensive thermodynamic properties, and what are they? Their internal energy H, and enthalpy. Sorry, H is the enthalpy, so U is the uh, four property are actually there. So H is the enthalpy, and U is the internal energy, internal energy, entropy, and specific heats. Okay, the Cp and Cv. This you all study in your you will study in your thermodynamics. Okay, so no need to worry about these things in this. Okay, we will little bit discuss. We will use it in the fluid subject also, but it's like a very nominal. Okay, and the other two properties that have to deal with the friction. Okay, so we will write at the frictional properties, and obviously two kind of frictional properties are there. The first one is having for simple flow, that is that only for flow. Okay, not to deal with the temperature or something, that is known as coefficient of viscosity. Coefficient of viscosity, and that is mu. And another one is thermal conductivity. Okay, so it has to deal with the temperature. Okay, so I mean this one is the thermal friction. Okay, we can say that this one is thermal friction, and it is thermal conductivity. Okay, so I hope one more point is there, that all of these 9, so there are 9 properties, like 3 4 3 7 7 to 9. Okay, total 9 properties. Okay, I mean total 9 properties. Okay, and all these 9 properties are true thermodynamic properties. Okay, so like true thermodynamic properties, and all of them are determined by thermodynamic condition or the state of the fluid. Okay, like in this case it will be determined by the thermodynamic properties, and it will be determined by the flow state of the fluid. Okay, so I hope these things are very clear to you. I will discuss all these properties quickly one by one in the upcoming lectures. Okay, so till then keep learning, and goodbye.